Here we are at page 70, number 9, solving quadratic equations. All right, so let's take a look at 9a. 3x squared minus 2x minus 2 equals 0. So when you're asked to solve, they're not being specific as to how they want you to solve it, right? But sometimes on a test they might say solve by factoring, solve by using the quadratic equation. In this case here, I mean, what I always suggest is if you can solve by factoring, let's go ahead and do that. Can you factor this? Right? Are there two numbers that multiply to give, right, -6 and add to give -2? Can I find two numbers that multiply to give -6 and add to give -2? I think I'm going to search for a long time and not be able to do that. Okay, so if you can't factor, then you go ahead and use your quadratic formula. So x is equal to -b, right, plus or minus b squared minus 4ac on 2a. So let's just sub into that. I mean, at the end of the day, this formula here always works, okay? So -b, let's not forget that this is your a, b, c. Your b is negative. So when you put your -2 in there, you're actually going to generate a positive value here, right? So it's going to be 2 plus or minus. Here I go with b squared. So my b is -2. I'm going to square it. Minus my 4 times my a times my c, right, on top of 2 multiplied by a. So what do I have? 2 plus or minus, right? Square root of 4 plus what? Right? 20, well, 4 times 3, 12 times 2, 24. So, and it's a positive, right? The two negatives generate the positive. So I now have this. I've got 2 plus or minus root 28 on 6. If you were to check the answer in the back of the textbook, this is not the right answer, okay? Because this 28 here is not fully reduced. So they're going to do this, right? Like we looked at in question 7, we can we can clean that 28 up because 28 is the product of 4 times 7. Remember, I'm trying to find a number that goes into the 28 for this in this example that has a nice square root, which in this case is 4. Okay, so now I have 2 plus or minus. If I was to split that up as root 4 times root 7, oops, a little multiplication there, over top of 6, I get 2 plus or minus root 4, which is 2, over times root 7 on 6. Now this is a little tricky, but I can because I see a 2 there, I see a 2 there, and I see that a 2 goes into that 6. I can go ahead and reduce like that. It'd be like me giving you this. If I gave you 3 plus 9 on 6, like we know the answer is what? 12, right? 12 on 6, we know the answer is 2. But I can get that 2 by going like this. 3 goes into itself once. 3 goes into 9 3 times. 3 goes into 6 twice. I'll still get that 2. Look, 1 plus 3 is 4. Divide by 2 gets me my 2. So as long as you can cancel everywhere, you go ahead and do it. But for example, if I had this now, if I had 3 plus 8 on 6, well, the answer is 11 on 6, which is on an almost 2, right? But if I start going like this, I'm not allowed to do something like this, okay? Because now look what I'm getting. I'm getting 9 on 2, which is 4.5, which is not the same as 11 on 6. So you can't do something like that. So the point is, if you can cancel everywhere on the top with that bottom number, go ahead and do it. But when I say everywhere, I mean numbers that are not in roots, right? That 6 is not in a root, so you can cancel it with these numbers because they're not in roots. Not that 7, okay, because it's in a root. So here I go, right? That 2 goes into itself once, goes into itself once, goes into that 6 3 times. So you're going to find the answer in the back of the book to be 1 plus minus root 7 on 3. Okay? Now, I don't know if some teachers accept this as an answer, but you might want to write that the roots are what? Your roots or your x-intercepts are 1 plus root 7 on 3 and 1 minus root 7 on 3. Okay, so that takes care of 9a. Yeah, I'll stop it at that and create another video for 9b.